This is one of those interview questions that looks simple, but actually tests whether you understand how to write clean, reusable, and production-grade Python code. The question is, what are Python decorators, and can you give an example from a data pipeline? Here's the simplest way to think about it. A decorator is like a smart wrapper that adds extra features to your function, without you changing its actual code. So, imagine you have a function that trains a machine learning model. Now you want to measure how long it takes, but you don't want to clutter that function with timing code. A decorator lets you wrap that function and automatically add the timing feature, cleanly and consistently. It's like putting a gift inside a box. The contents stay the same, but the box adds presentation and structure. In Python, we use the @ sign to apply decorators. It's just a cleaner way to attach extra functionality like logging, validation, retries, or caching. In interviews, they're looking for two things. Do you understand how decorators help keep your logic clean and modular? And can you show where you'd actually use one in a real data workflow? Let's look at how decorators actually work. In this example, we define a timer decorator. It measures how long any function takes to run. Inside it, we first record the start time, then call the original function, and finally calculate how long it took. Instead of changing the function itself, we simply wrap it. Then, by writing a timer above any function, like our model training function, Python automatically applies the decorator. That means every time the function runs, it prints its duration, without us writing a single extra line inside the original code. This is the beauty of decorators. They let you extend functionality transparently, keeping your core logic simple and focused. Now, let's connect this to a real project scenario. In one of my ML pipelines, I built a cache result decorator that stored expensive feature computation results in Redis. Normally, these transformations took around 45 minutes on repeated runs. But by caching the results using the decorator, I reduced it to just 8 minutes, without changing a single transformation function. The decorator handled all the caching logic, keeping the business code clean and reusable. That's a perfect way to answer in an interview. It's technical but practical. You can also mention other real-world decorators, at retry for handling flaky API calls, at validate schema for input validation, at log performance for monitoring, and authentication for endpoint security. So, if you ever want to sound like someone who writes production-level Python, decorators are your best friend. They show that you understand modularity, reusability, and clean architecture.